Okay, so I am back. So what I've done in the meantime is actually I've gone ahead and set up all the various functions on these items as I've mentioned previously. So what I'm going to do now is just go through and kind of show you some of them and how they're set up. So some of them are fairly straightforward, like the get name here, where it is just returning the value of the name. And again, as a reminder, the reason why is because the variable itself is private, and that's to prevent us from being able to change the value somewhere else outside of this particular class. So we are currently on the main item base, so I'm just going to go ahead and go through each function. You kind of see how they're set up. So display name, again, fairly straightforward. Now, in terms of the get description, this one's a little bit different, and my thinking behind it was that we don't really need two individual functions for the description to return either the short or the long. We can kind of just do the same thing with get description, and then just pass in a variable to say, do you want to return the long description or the short one? So it's quite nice and straightforward. So in terms of how that node looks, it just looks like that. So again, we can just, depending on what we want to return, we can do that there. I have noticed that the name there on the output actually has short, so I can remove that. There we go. Oh, it's always fun when that happens. So what's happened here is we've renamed the return value, but for some reason it's renamed one of the variables as well on the node. It doesn't name the actual variable, thankfully, but yeah. Okay, so this is what the node looks like, and if we want to return either long or short, we've got a variable there to control that. Now, the next one is get stackable. Again, nothing special about that one. Same with get weight. We do then have one here called get mutable data. Now, I'll go into that a little more detail shortly, but this itself is more for the child classes that we would set up with the item base. So at the moment that's just empty. It's just set up so it's available for all items when it's needed. We then have the get mesh. Again, nothing crazy on that one. Same with the get hit sound. Now for the get 3D display data, this one's a little bit different because we're actually returning a few values here, as you can see. So this is what the node would look like. Now, with the way that this is set up, we can specify a display mesh, but I was kind of thinking that if it wasn't set, then it would just automatically use the one that's specified for the world. So this here just kind of gives you an option to display a slightly different item. It might be that you want like a low poly version of the mesh possibly for the world, I don't know, but then maybe on the display you might want a more high poly version. Options as it were. So this is kind of just set up to kind of handle that automatically, so it's not something that when setting that side of things up we have to worry about. We can just get this particular function and it will just automatically return one essentially. So here we just check, is the display mesh a valid soft reference? If it is, then great, we'll use that one. If not, then we use the get mesh. Now you'll probably notice here that I don't actually use this variable directly, so instead we still use the getter function that we set up here, and the reason why is because there may be instances, it's unlikely but you never know, there may be instances where in a child class you might actually want to override the get mesh function and perhaps do something a little bit funky there. As an example, you might want to change the mesh depending on the time of day. I don't know. It's not a standard behaviour for all items, but there may be a specific class that does that, and then you can kind of override the get mesh and then do a little check what time of day it is and then return the corresponding mesh, as an example. So that's kind of what it's kind of why we use that instead of going directly to this one here. Okay, so the next one is get icon. Again, nothing special. And lastly, we have the get should group. This itself is mainly for non-stackable items, where in the UI the idea is that we kind of group them together, so so you can kind of then sort of expand it to view the individual item data. But yeah, so again, that's kind of a quick overview on the classes there on the base item. What I'm going to do now is move over to the ammo. Again, this is just an example based on how I'm setting it up for this specific project. So hopefully it'll give you some ideas of how you can kind of set some of your things up as well. Now, for this particular project, we're kind of going on the basis that ammo is kind of like ammo clips, and when you reload, you're essentially swapping the ammo clip. So each ammo clip has its own amount of rounds in it, so that can vary depending on the type of ammo. So what I've gone ahead and done is actually set up some functions in here to facilitate getting some of that data a little bit more easily. So the first one is get rounds. So this one just returns the max capacity and then the current rounds in this particular clip. The next two functions are actually functions in terms of actually adding rounds and removing them. So for the add rounds, again, just a little bit of maths. So here we just take the rounds we currently have and we add the amount we pass in, and we just store that temporarily in a local variable called new total, and then we can clamp that value based on the max capacity to set the new one. Now in terms of this particular function, it does return the amount that it wasn't able to add. So let's say you attempt to add 10 rounds and the capacity of the a particular clip is say 30, but there was already 25 in there, so it means there would be 5 rounds it wouldn't be able to actually fit in. So that kind of allows us to do some additional things as of when we need to. So just to calculate that, we then set the new total and just minus what we actually set, and whatever gets returned here would be the amount that wasn't able to be added. So that's just how that's one works. And in terms of remove rounds, this is kind of a similar sort of method. The only difference here, we use the subtract instead. And at the end here, we do swap around how we calculate this. So this time we start with the rounds, and then we subtract the new total. So that could potentially give us a negative number, so we then just abs that. So in theory, this number should always be 0 or a negative number. So then we'll just turn that into the absolute positive value and return that instead. Okay, so then the next one we have is get damage. So again, that just returns the damage value here. So in terms of the thought behind that is that the weapon would have its sort of like a base power, and then it would kind of get modified based on the ammo type. So certain ammos can have slightly more damage, and depending on the weapon it's being fired from, it kind of all gets combined together, which we'll sort of see a little bit shortly. But that's just a quick way of getting the damage value from the ammo. And again, similarly for the recoil, again, some ammo types might have might cause a little bit more recoil than other ammos. And then lastly, we have the get mutable data. So this is one that we're actually overriding. So if you remember a few moments ago, I was talking about that function here. And that's what we're overriding here. So in a lot of cases, the get mutable data, that's more for getting data that would change from the base class. Change from the defaults, that's probably a better way to put it. So at runtime, there may be times where values will change. And in this particular class, one of those is the rounds that this particular clip has. So we need to be able to get that data and then store it at some point when we get to sort of saving and things like that. So this is just a way to help facilitate that. So I've opted to go for the instanced structure approach. So what I have done is created some structures for the mutable data. So this one's specific for the ammo, and then this one's specific for the weapon, so we'll look at that one shortly. So start by just taking the value from the parent, storing that in a local variable, and that's just to make it a little bit easier to add a new entry to it, which we'll get to in a second. What we then do is we make a new instance struct, and we use the make item data ammo, and then we'll just supply in the ammo. And it's kind of and so it essentially adds a new instance struct with the data in there. So this is quite nice. So if at some point we decide that maybe we want to add something a little bit extra, maybe we decide that all base ammo needs something else. It's unlikely, but you never know. But we can kind of just add that to the struct and then just pop it in, and that'll just add an entry in the current data array, and that then gets passed through the return node. So in terms of the way that child classes work, if we were to then make a child class of ammo, and we actually wanted some additional data on a child class, again we can create a child, we can override that get mutable, which is essentially what this is here, and then so rinse and repeat essentially. We can just add down the line, as it were, the data that we need. Okay, now moving on to the weapon. So there's quite a few more functions in here. So the first one is get supported ammo. Again, nothing fancy there. We then have get current ammo clip. Again, that's just returning the variable here. Again, the reason why this is private is because we don't want things outside of the weapon determining what the ammo clip is for the weapon. It should be the weapon that always decides what happens. Okay. Similarly, remove. Not entirely sure how we're going to handle that yet, but for now that just clears the object. We'll probably want to add a little bit more. We then have a set ammo clip. So this is where we essentially specify what the item ammo object is that we want to set it to. Then does a few checks and returns true or false for whether or not it's successfully done so. Now I've decided to set it up where if there's already a valid ammo clip, then it will just automatically fail, so it will return false and essentially does nothing. So the idea is that if you're wanting to set the ammo clip, then you should eject it or remove it first beforehand. That just makes it easier and a bit more consistent when, let's say, wanting to do an animation for removing the ammo, for example. It kind of makes sure that that's always happening, so we're not just overriding the ammo clips and removing that type of thing. The next sort of bit that we do here is we again get the supported ammo, and we just check to see if the new ammo clip that we're trying to set it to is actually a supported ammo type. It's more of a bit of a fail-safe, so I don't know. So we've got rockets as an ammo, and we're trying to use it in a handgun. It just doesn't make sense that we'd even be able to set that as an ammo clip. As an ammo type. So in this particular example, we just check that. Because the supported ammo is a soft class reference, we just get the class of the inputted one. It's one that we're trying to set it to. Convert that to a soft class reference, and then we can compare the two. So it's quite a nice way of being able to check without having to do a specific class, a specific cast to a specific type of ammo. Because at this point we don't really care. It's just type of thing. Assuming that all passes, then we can actually go ahead and set, and then we return true. So there's a little bit more involved on that particular function, but hopefully that makes a little bit of sense. Again, chances are if you're setting your own infantry up, you kind of set it up how it is that you need it, but hopefully this will give you some ideas and some inspiration on how you can set yours up. Now the next one we have is get has ammo. Now I've actually realised that this function is incomplete. So currently what we do is we get the current ammo clip, we get the rounds from it, and we just check to make sure that's above 0. However, there is one edge case here that I've not accounted for, so I'll quickly do that now. And that's checking, is the ammo clip actually valid? So if we don't actually have an ammo clip in it, then we don't have any ammo, so we can just return false straight away. So that's just nice and easy there. Okay, now the next few things that we have on the list that I've set up for this specific weapon class, and that's the get base damage and calculate base damage. Now, again, in terms of the overall sort of base damage, let me actually rename that there to base damage, just so it's a bit clearer, just because there may be other modifiers you want to add based on what gets hit and things like that. But in essence, we have this sort of mediary function called calculate base damage. And the general idea is that this particular function would be could be overridden by child classes of the weapon. So if you wanted to modify how the overall base damage is calculated for a specific class, it kind of gives you that option too. Currently, there isn't anything actually set up in here. It just returns 1 for now. But at some point we might decide that the total damage would be, I don't know, just these two values multiplied together, as an example. And that could just be what ends up happening, I don't know. But for now, I'm just going to leave that blank, and it's probably something I'll come back to at a later date when we're in a position to actually test these things a little bit more in terms of how they work. Now, in terms of what actually gets passed in, again, we use the power here. Although, as I think about it, I should... actually, no, I don't think... As I think about it, I don't think there's any particular reason why you would need to get the power specifically. Although, as I think about it, for the UI, actually might need to... and I've not actually done that function. So, quickly add that one, so get power. I'll click that to pure function. And I am actually going to go ahead and actually swap out this as well, just to make sure it's consistent. Again, the reason why we do it as the function here is, again, you might want to have some edge case where if the player is in a specific room, then you get double damage. I don't know, just for that particular weapon. So again, in the child class, you could override the get power and potentially modify how that works. Okay, so again, and then for the ammo damage, we get the current ammo clip and get the damage. And again, there is an edge case I have not considered, and that is if this is not valid. So we do need to check for that. So do we actually have ammo? So if that is valid, we can come and do this. If it's not valid, we may as well just return 0. And this will just prevent us from accidentally applying damage when we don't actually have any ammo loaded into the weapon. Again, there's a couple of ways you could probably handle this. It's just the way that I'm handling it in this particular scenario. Okay, so that's for the damage. The next one is the get recoil. So again, when the weapon's being shot, you might want to add a little bit of recoil that gets applied. Similar sort of setup here. We have the intermediary function that again can be overridden. Technically, you could override the get base recoil, but sometimes it's nice to have different functions. So the overall functionality here, you probably want the same, but it might just be this bit that you want to change. Again, I have noticed that we don't actually have a check here for if this is valid. So again, I'm just going to do something similar to the damage, and if we have no ammo, then the recoil is going to be 0. Yep, and then we have the fire rate and the get held class. Again, nothing fancy there. Okay, so the last one on the list here is the get mutable data. So again, it's something that's overridden from the item-based class. Now, the reason why is because we do have the current ammo clip, which can change at runtime. So it's something that we kind of need to keep track of. So again, we start off by just storing the data from the parent class in a local variable. Again, that's just for convenience. What we then do is we come up and we actually check to see if we have a current ammo clip. If we don't, then we don't really do anything. If it is, then we can get the mutable data from the ammo clip. We then store that in, again, a local variable, and then we just get the actual class as a soft reference from that particular ammo clip. And then once that's all been done, we come down here and we'll make an instance struct of that particular data. So in this case, we will get the ammo class, that we set up here, and the ammo data, which again we set up here, and then we add that to the array. Now, as I think about it, actually adding this entry might not be necessary if the class isn't valid, as if there's no ammo. So I'm just going to quickly rework this. So what I'm actually going to do is like this. So if it is valid, we'll set all those variables, and then we'll come up here and do this. If it's not valid, so there is no ammo clip, then I'm just going to come down here and do that, and just return what the current data is up here. Again, if there's more sort of data that could change at runtime that we need to actually store, again, the way this function is set up could end up needing to be changed. But in terms of the data I currently have in there, this is how it's been set up. So in essence, when at runtime, if we need to recreate this particular weapon, we'd be able to also recreate the current ammo clip that's inside. The thinking there is that if we actually reload a weapon, the ammo clip that gets put in gets removed from whatever infantry it's in, so generally the player, because it's no longer in the infantry, it's in the weapon, if that makes sense. So yeah, so that's kind of the thought process behind that. Okay, so yeah, so that's some of the item classes there that have been set up, some of the functions. Again, it's setting up infantry systems can be quite complex, so I do definitely recommend just taking your time and just thinking about what it is that you're wanting and sort of the data that you need, and actually really consider how it is that data is going to be structured, because once you get quite far into your infantry system, it becomes extremely difficult to restructure that core data, as it were. So making sure that you've got a good foundation to start with can obviously be quite important. Okay, so in terms of that, at this particular point, I believe we're probably getting ready to start setting up the actual infantry system component. These are just some functions from some of these. So anyway, so this is just inside an infantry system component, and I already have a variable in here which is a map where we have the item base class here, well, item base object here, and an integer. So generally, if an item is stackable, so we have the get is stackable here, I'm going to kind of go on the basis that its item object itself isn't actually that relevant per se, so we can kind of just find one in the list of the same class and just increment the number, and then the one we attempted to add we can just remove. And if we then want to remove it from the infantry, we can just create a new item object of the same class and then decrease the number by 1. That's the general idea I'm going for here. So in terms of the integer here, this would denote the actual quantity of a given item of that specific type. However, if it's not stackable, then the integer will always be 1, because it would always be, there'd essentially be multiple types of a given class if they're added in. Like ammo, for example, there might be a limit. So yes, that's kind of the idea I'm going for. Now, as a quick reminder, let's quickly jump in. In terms of the way the infantry is visibly, I do apologise. Again, if I pick some items up.
Day 3. The printing of the platinum. Where should the stuff be taken?
But yeah, so visibly it's just a list essentially. What, any item data there? So we don't need anything such as, we're not doing like a grid or anything like that. All the items will just be listed in the list. So it's fairly straightforward there. We can just quite easily get the keys, and then whatever's in the list here would essentially be an entry in the list. So we're not needing to worry about position or anything like that. Certainly not at this stage anyway. Okay.